So 3 is just extending to what we've been doing. We have a rational function, we want domain, but now we're actually going to list the vertical and horizontal asymptotes, which is fine because when you're finding the domain, you have to find the vertical asymptotes anyway. So to find those, you take the denominator and you set it equal to 0. So I have x cubed minus 9x equals 0. And I can factor this because I have a common term. These both have x. So I'm going to take out an x, and I'm left with x squared minus 9. And now I'm going to set each factor equal to 0. X is a factor, it equals 0. And then x squared minus 9 equals 0. Do you remember how to solve this? Add 9. X squared equals 9. And then to get rid of a square, use square root. So x equals plus or minus 3. Whenever you take a square root of something, remember our answers are plus or minus. So this one, it looks like has 3 asymptotes, and I'm going to graph it just to check my work. So 4x minus 5 divided by x cubed minus 9x. And I can see on the graph my 3 asymptotes. X equals 0, x equals positive 3, and x equals negative 3. So look how many pieces of the graph we have. That's going to tell us our domain. 1, 2, 3, 4. We're going to have 3 unions in our domain because there's 4 chunks of graph. So first, I'm going to type in my asymptotes. I have x equals 0, x equals negative 3, and x equals positive 3. Now let's go back to domain. So I have negative infinity out here till really, really, really close to negative 3. So I write that as negative infinity, comma, negative 3, and I use a parenthesis, union. Okay, now my next part is this piece, this U shape that's upside down. It's really, really close to negative 3. And then it ends at really, really close to 0. So I'm going to put 0. Okay, union, next chunk, really, really close to 0. And then really, really close to 3. And we're using parentheses because we're actually not including 0. We're not including 3. Okay, last one picks up at 3 right here, really, really close to 3. And it goes out forever to infinity. So notice how we always repeat the numbers on the next interval, and then we end with negative infinity to infinity. Let me move my windows back. Okay, and our last thing is we're reviewing horizontal asymptotes. So remember there's 3 rules for that, and we have to look at the degree of the top and the bottom. So how many x's? So on our numerator, that's degree 1. And then on the denominator, what's the highest exponent? 3. So when the denominator has a larger degree, so denominator is greater than the numerator, then y equals 0 is the asymptote. Okay. And on this graph, it goes through right there. Like if you're like, well, what about the graph? Once you hit degree 3, the graph behaves a little different, but that's still an asymptote at our endpoints. Okay, so y equals 0 is our horizontal.